Okay, Algebra 1, Lesson 64, we're going to talk about identifying, writing, and graphing inverse variations. Inverse variation. Have we talked about direct variation? Yeah? Direct variation is y equals kx, correct? Where k is the constant, and there's a direct relationship. So in a direct variation, as x increases, y increases. As x as x decreases, y decreases, that type of thing, okay? So that's direct variation. We want to recall that direct variation occurs between two variables at y equals kx and k equals 0. Another type of variation called inverse variation can occur between two variables. Inverse variation is a relationship between two variables whose product is a constant. So the product is a constant. If we wanted to find a constant in a direct variation, we're finding the quotient of y and x, right? Do we remember doing that? Okay, if I want to find the constant in direct, I divide y by x to find my constant. In inverse variation, the formula is actually y equals k over x. Okay, that's our formula for inverse variation. Y equals k over x, or constant divided by the x variable. So in order, if I wanted to find the constant here, right, I wanted to solve for k, what would I have to do to solve for k, or to get k by itself? Multiply by x on both sides, good. So I'd multiply by x, so k would equal xy or yx, right? So the constant is the product of x, the product of xy, and you see that down here. Okay, where k is a non-zero constant, okay, defines an inverse variation between x and y, and the variable y is said to vary inversely with x. So let's talk about some real-world situations where you might look at two things that have an inverse relationship. That means as one increases, the other decreases. I would say that as the temperature rises, right, something that's increasing, what might decrease as temperature increases? How about percent chance of snow? Okay, so it's a possibility, right? As temperature increases. That now, if you're starting from really, really low, that doesn't always necessarily work that way. So let's try something else. How about as temperature rises, number of people wearing coats might decrease, right? Even if you started at really, really low temperatures, right? Or let's say as temperature increases, the number of layers decreases, right? I think right now I have on a t-shirt, I have on like some sort of like thin, like, I don't know, type of overshirt thing, zip up deal. And then I have a hoodie on, and if I were to go outside, I'm going to throw a coat on over that. But as I come inside, I drop the coat, so my layers decreased. Hello? Yes, I do. Sure. Jeremy, you need to go to the office. Okay. So, for how many of you was that true? When you came inside, you dropped a layer? Yeah? Pretty much everybody in here. So as you came into a place where temperature increased, the number of layers that you wore decreased, right? And we kind of see that happen in the summer, right? You get down to a t-shirt, you get down to shorts or whatever it is, okay, that type of thing. So we understand inverse relationship a little bit. Now, there is, the opposite could be true with temperature, and we could talk about different things that have inverse relationships or inverse variation. Okay, in a direct variation, y is equal to the product of the constant of variation k and x, meaning that we saw y equaled kx, k times x, the product. However, in an inverse variation, y is equal to the quotient. We see y equals k over x, which we've already looked at. Okay. For every ordered pair in an inverse variation, x times y is going to be equal to my constant. And this relationship can be used to find missing values in relationship. So because we're talking about x and y values, we're talking about things that can be plotted on a graph or on a coordinate plane, right? If I know what my x and y are, I can make a little point in those positions, correct? And we can see this, we can connect them with a line, or we can see a scatter plot and begin to look at what that relationship looks like. Does it look like it's going up, or does it look like it's coming down? Okay? So we have a product rule for inverse variation, meaning that if I have coordinate x1, y1, and coordinate x2, y2, which are just two separate coordinates, the solution of an inverse variation would be x1, y1 equals x2, y2. Okay, you see this rule show up on page 419 in your book. Okay, hopefully we'll see more about that here in a little bit. In a direct variation, if there's at least one known value for x and y pair, the constant of variation can be determined. The same holds true for an inverse variation. If we know at least one value for x and y pair, then the constant of variation can be determined by just using simple multiplication. Right? We multiply the x times the y and we can find the constant. Okay? If we know the constant in one of the variables, we can find the other variable. All this work for us so far? Did I lose anybody at any point? How many of you are just bored out of your minds? Okay, nobody raised their hand. Just not because you're being honest, but because you're being nice, and I appreciate that. Let's see, let's take a look here. Okay, let's look at a couple of questions. Let's see, what time are we out of here, though? 48 doesn't leave us with a whole lot of time. All right, so let's do this then on 64. Let us find a question from your homework that you want to ask so we don't miss an opportunity to answer a question. So we have about 7 minutes here. Okay, let's take a look at maybe something like A, right, where we see 4y equals x. Okay, and notice how they say, we want to know, is this an inverse variation? Okay, well, real quick, what is our equation for inverse variation? It's y equals, is it kx or is that direct? K over x, right? All right, is this an inverse variation? Look at where x and y are in relation to each other. No, right? Because if I wanted to solve, let's say I wanted to solve for, what does 4 represent in this equation that they've given us? It represents k. Well, that's not how we show inverse variation, is it? Okay. So what we're saying is that the equation solved for y should be, what should this be? Well, let's come over here to our right-hand equation. We said that k was 4, right? So it should be y equals 4 over x, right? Okay? So what we would say is that this does not match the inverse variation equation. Okay, does that make sense? Because it should look like this. Notice in this question it says to explain. So is that enough of an explanation, or might I actually need to write a sentence? Explanation means to describe, explain, write a sentence. Okay? So if you don't want this question handed back to you with a 0 on your paper and saying, hey, you need to go back and redo A, then give me a sentence. Okay, I'll just give you a for instance. It says this is not an inverse variation. The equation solved for y is y equals x over 4. This equation does not match the inverse variation equation, y equals k over x. Okay. And I don't know, I almost kind of disagree because they're telling me, yeah, because even if I were to move this, right, I would divide by 4. They're saying y equals x over 4. That is incorrect. All right, so this equation does not match the inverse variation equation of y equals k over x. Any other questions before we close out here from your homework? Okay, are we concerned about B? No? Yes? See, somebody's kind of concerned about B. Okay, well, B, what does B say? B says something like 3xy equals 9. Okay? So again, let's solve for y in this equation, and let's see if it matches our inverse variation of y equals k over x. Okay? If I wanted to solve for y in this equation, what would I need to do? First, divide by 3, right? Okay, well, that's going to give me xy equals what? 3. Okay, now what would I do to solve for y? Divide by x. Divide by x. So I get y equals 3 over x. Does that match the equation of y equals k over x? Yes. Okay, where we would say my constant is 3. So here I would say, yeah, this is an inverse variation. The equation solve for y is y equals 3 over x. The equation matches the inverse variation equation, y equals k over x. Okay, I'm showing you mathematically you need to write a sentence. Okay, does that work for you? Okay, so hopefully that gives you a little bit of a start. We've done 2, right? We've done A and B. I think this just goes through E and then plus some other stuff, but I think this is only like maybe 13 questions in your homework today. All right, I'm going to stop there.